This is video number 3 for Year 10 Science, looking at motion. Continuing on from the previous video on equations of motion, I introduced these equations here. V equals u plus at, S equals ut plus a half at squared, and v squared is u squared plus 2as. These are your main equations of motion. You need to get comfy with these, know how to use them. So v is the final velocity. Okay, v for velocity. Velocity is the same thing as speed, but with a direction. So for example, 10 meters per second southwest. That's velocity. U is the initial velocity. Okay, what you start off with. So U is the initial velocity, what you start off with. V is the final velocity, what you finish with. A is the acceleration. And T is time. And S is displacement. Displacement is a measure of how far you are from your starting point. It's a measure of distance, basically, or with the direction. These are also known as the SUVAT equations. SUVAT. Why are they called SUVAT? Well, it's because of the 5 key variables, the 5 key things that typically used in the study of motion. S is displacement. U is initial velocity, V is final velocity, A is acceleration, T is time. So you can work out all of these 5 variables, 5 things, using these 3 formulas here, equations. Let's do some examples to see how they work. Example 1. Suppose a car starts from rest and accelerates 2 meters, I should say at 2 meters per second squared for 4 seconds. What's its final velocity? Question mark. Okay, it looks a bit wordy, a bit complicated, but it really isn't. Once again, let's break it down. Step 1, given. Now, the thing to note here, from rest, whenever you see this in physics, from rest means your initial velocity is 0. Because we need to find final velocity, right? V, we don't know what that is. If we're given V, surely U is also given. But in this case, it's implicitly given. It's not directly given, it's 0. So U is 0 meters per second, to be more accurate. V is unknown. Accelerates, so the acceleration is 2 meters per second squared. Now I should say acceleration has units, meters per second squared, because, so here's an aside, if you recall from the formula for acceleration, A equals V minus U over T. And by the way, you can actually get this from V equals U plus AT. If you rearrange this, you can get back A. So that's a trick for you. The units in the numerator, so velocity, change of velocity, is meters per second. And the units of the denominator, time, typically seconds. So that's how you get meters per second squared. Just an aside. Anyway, okay, we need to work out V. And we're also given T, I should say, 4 seconds. So that's really the hard bit. The easy bit is just working out which of these SUVAT equations we need to use. Now, we're given U, A, T, we need V. If you think about it, we should be using this here, the first one. V equals U plus AT. We can't use S, because the S equation, we can't use these two, because we don't know what S is, okay? And there'll be 2 unknowns, which is not really going to be good for you to use to solve. So we need to use V equals U plus AT. Step 3 is to sub and solve. Let's do it. V equals U is 0, plus A is 2, acceleration, T is 4 seconds. If you can't do it in your head, use a calculator, 2 times 4. So 0 plus 2 times 4, that's 8 meters per second, because it's velocity. So that's how you use one of the SUVAT equations to find velocity, final velocity. Let's do another one. Okay, a train accelerates uniformly from rest at 1.5 meters per second squared for 10 seconds. How far does it travel? Step 1, given. Okay, we need to work out how far does it travel. Now, how far means distance. Now, we don't have distance here. Technically speaking, it's displacement. So we need S. We need to work out S. How far means S? Question mark. From rest, U is 0 meters per second. Okay, if you're just sitting there in your chair watching this, your initial velocity is 0 meters per second. Okay, if you're at rest. And if you then decide to get up and move. This here is acceleration, 1.5 meters per second squared. Okay, because it accelerates at this acceleration for 10 seconds. That's T. T is 10 seconds. Number 2, we need to use one of the SUVAT equations. Now, how far? Now, we need S. We're given U, A, and T. Let's go back up to here. So use your formula sheet. When you're solving these problems, use a formula sheet and calculator. So U, A, and T. We can use this one here. We're not given V, right? We're given U, A, and T. So let's use this one. It's just really figuring out which one to use. That's all it is, really. That's where students get most mixed up. Number 3, sub and solve. And you see how systematic this process is? Just start step by step, work your way through, and you get the hang of it. So U is 0. That makes things easy. U times 10. Okay, this is actually 0. But anyway, plus you have to show full working out in any exam. Plus a half. Acceleration's 1.5. So a half times 1.5 times T squared, which is 10 squared. If you plug that into your calculator, you get 75 meters. Meters. Why is it meters? Because we're using velocity meters per second. It has to be meters. So I need to check there. And that is your displacement. It travels 75 meters. Let's do another one. Example 3. A car increases its speed from 10 meters per second to 25 meters per second over a distance of 105 meters. What's its acceleration? Wordy once again, that's okay. That's fine. Given a car increases its speed from 10 meters per second to 25 meters per second. From means that's your initial velocity. U is 10 meters per second. To 25 meters per second, that's your final velocity, V, over a distance of 105 meters. So that's S displacement, 105 meters. We can't use D, we have to use S. We have to use the SUVAT equations. So we need to find acceleration A. So what do we need? We need to use one of these formulas. We're only given S, U, and V. Let's go back up. S, U, and V. Think about it. S, U, and V. We need to use this one here. Even though it doesn't show you exactly how to calculate acceleration, you can rearrange it using algebra. So let's use this. V squared is U squared plus 2AS. Step 3, sub and solve. Okay, V squared, it's 25. 25 squared is equal to U squared, which is 10 meters per second squared, plus 2A, A is unknown, S is 105. So 25 squared, that's 625. 10 squared is 100. 2 times 105 times A. That's the same thing as saying 2 times A times 105. You will get 210A. This is algebra. This is maths. Let's do it. So what you do is, to get A by itself, step by step, let's take this guy over. 625 minus 100, that's 525, equals 210A. The 210A stays there. How do you get A by itself? You divide both sides by 210. So here they cancel out. So A is therefore 525 divided by 210 you get 2.5 meters per second squared. Remember, the units are 2.5 meters per second squared. Meters per second squared are the units for acceleration. So hopefully this is making sense. Just a simple recipe, knowing what to use. I will do one more in this video. Example 4. Ball is thrown upward at 15 meters per second. How long does it take to reach its highest point? And it says here, take acceleration A to equal 9.8 meters per second squared. Okay, it looks complicated, but it really isn't. Step 1, given. Upwards at 15 meters per second. How long does it take to reach its highest point? Now, this is where you have to think outside the box. When you throw a ball upwards, it eventually stops momentarily for a split second, then comes back down. Why does it stop? It actually stops at the top. Its velocity is 0. It stops because it needs to change direction. In order to change direction, you have to change speed. So to go from 15 meters per second, that's the initial velocity, to a final velocity of 0. Because it's asking about the highest point. The highest point in anything's, when you throw something up and it comes back down, the highest point is where it stops. So where it stops, that's a velocity of 0 meters per second. How long does it take? We need t. T is unknown. And we're given acceleration 9.8 meters per second squared. Now 9.8 meters per second squared, that's gravity. That's how fast gravity acts, how fast it causes something to accelerate. That's more or less year 11, year 12 stuff. But anyway, we need to work out t. Now we're given u, we're given v, we're given a. So what can we use for this? U, v, and a. Well, if you think about it, the first one, u, v, and a. We're not given displacement, we're only given those three. So number 2, we need v equals u plus at. So have a think about this once again. If you throw it up, so it's thrown upwards at 15 meters per second. That's the initial velocity u. Okay, you're throwing it with some initial speed. Highest point, velocity is 0. Just think about it. You can even try it now if you want. Grab a ball or something, anything. Just throw it up in the air. You can use a slow-mo cam on your phone and just watch it momentarily stop in midair. Its speed is 0. Then it comes back down. It accelerates again. Step 3, sub and solve. Let's find t. So v is 0 equals u. U is 15. A is 9.8. T. This is algebra. Take the 15 over. It becomes a minus. Minus 15 is 9.8 t. So find t. Divide both sides by 9.8. So t is just 15 minus 15 on 9.8. Oh, sorry, what have I done? That should be minus, sorry. Minus 9.8 meters per second squared. Okay, the acceleration due to gravity, this number here is minus. Minus means it's going downwards. Okay, acceleration is a vector. It's got a direction. Gravity is a vector. It acts downwards. So it's 9.8 meters per second squared downwards. The minus means downwards. If gravity acts upwards, it'll be a plus 9.8. So there should be a minus here. Okay, put minus there, so that it's plus minus, which is just minus. Minus, and the minus and minus cancel out. So minus 15 divided by minus 9.8 is just 15 on 9.8. Calculator, you get around 1.53 seconds to 2 decimal places. So that's your time there. I suggest using or making up your own questions using the SUVAT equations to help you, or using my examples here to help you. But that's literally the SUVAT equations. That's how you use them. I'll be making more videos, so stay tuned.